Right. We continue with another example. Another example where we're explaining how we can use canal maps in simplifying Boolean functions. We just give an example with two variables. Probably will not be sufficient for your understanding, for you to understand, for you to understand. Yes, for you to understand. Right, so we have a three variable example for you with f equal to f is equal to sum of min terms 1, 5, 2, 6, 7. We said if you are not following and you don't understand what we've been doing all along, you can go on and find your truth table. From the truth table, you can go to the K map. But if somehow understand what we've been blabbering about all this time, you can go directly from the shorthand notation to the K map. How do you do that? We already know if a min term is on the shorthand notation, it means its output is equal to 1. It means for the min term, which represents 1, which is 001, its output is 1. We know that if we have three variables, we have 8 possible outputs. 1, 2, 3, 4. It means we have 8 possible outputs. With 8 possible outputs comes 8 squares on your canal map. 8 squares on your canal map. Personally, I like using A and BC. Other people can do this. They can do this. Believe me, you still come up with the same answer. 1, 2, 3, 4. So this will be maybe they can say A, B here and C here. So for this part, we already mentioned you need to know they use gray code for numbering this part 0, 0, 0, 1, 1, 1, 1, 0. So it will be the same for this one. This is 0, 0, 0, 1, 1, 1, 1, 0. This is 0, this is 1. This is 0, this is 1. You will come up with the same answers. I just prefer, not that I prefer. Whoever taught me this preferred this one and it got stuck. So I'll be using this one for explanations. Right. So here we are. For the output, what is the output for 000? Participation.
0.
This is 0. This is
That's 1.
1.
1.
This is
0.
1. 1, 0. Here.
0.
0. Let's continue. This is 101. Those who are in the chat, unfortunately, I cannot. Frederick. I cannot participate as much with you. Unmute yourselves. Right. Here, 101. 421. This
It's
is 1.
1.
111. 1.
1 and 1.
1. How true is this? 0, 1. This is false.
That is 0.
That is 0. Thank you very much.
That is 0 there.
That is 0. Right. This is correct.
0, 1, 0 is 1.
Yes. I think this is correct. This is our canal map. We just went from this shortened notation directly to the canal map. For those who don't understand, yeah, Francis is raising his hand. For those who don't understand,
Say,
yes,
isn't 0, 1, 0 supposed to be 1?
0, 1, here, 1 here.
I know the last one.
This one.
Yes.
Thank you very much. True.
It's a 1.
It's a 1. Thank you very much. Voila. Francis, which department? Which department are you
Yes.
from? Yet.
Yes.
Okay. There you go, being noticed. Good for you. All right, 0101 0111. I think we are open right. This is our Kano map. Now we go to the simplifying part. How do you simplify? For sum of products, simplifying, the simplifying part, right? For sum of products, you look at the ones. If you are using sum of products, in this example, we are using sum of products. I think we can agree because this is the sum of midterms. This is the sum of products. If you are using sum of products, you look at the ones. You loop the ones. What do we mean by loop? You group them. You group the ones. You group the ones into groups of dimensions of power 2, starting with the largest. Groups of dimensions x to the power 2. 1 to the power of 2, 1 to the power of 2, 4. No, it's be 2 to the power of x. I think so. 2 to the power of 1, 2, 4. Right. Starting with the largest. Starting with largest. So what we mean, if you have, let's say, 1, that's too much. If you have a Kano map like this, maybe there's 1, 1, 1, 1, 1, 1, 1, 1. 8 outputs, all of them they are ones. What you start doing, you start grouping the largest numbers. So for here, I can start grouping 2, 4, 8, 16, etc. The largest in this case is 8. So it means I group the whole 8. It will be not okay to group them in 4s like this. It would not be okay because there is a larger group. You start with the largest group. That's a very important point. You start with the largest group. So if I have something like this, starting with the largest group, I group them as a whole. This is how you loop, starting with the largest. So if I have maybe, let us change it a bit. Let's say we have a 0 here. I can no longer loop them as a group of 8. Now I can group them, maybe starting with the largest, I can group this 4, then I group this 4 again, this 4. And these loops, they can overlap. That's another thing to watch. These groups, they can overlap. I can group these 4 here, these 2, and these 2 here. They can overlap. It's like I'm grouping these 2 here. That's another group of 4. I can also group these 2 here. So I have 3 groups there. That's how you make your loops. If you don't loop them starting with the largest, your expression will be, or let me say your circuit will be very big. You will not have simplified, which is the main goal of these Kano maps. If you start with the smaller groups, it means you're not simplifying anything. You start with the largest groups. So here we have this group in blue, we have that group in red, and the other one in, is that yellow? I think so. The other one in yellow. That's how you start your simplifying. If you are using sum of products, you look at the, if we are using sum of products, you look at the ones. We don't care about the zeros. We look at the ones, you group the ones starting with the largest group. So it's either you group them in twos, in fours, in eights, in 16s, and depending on the number of input variables you have, it can reach 2 to the 2 to the power of, you never know, millions of bits there. Right. Now going back to our example, how do we group in our example here? I can identify, do we have a group of fours? Yeah. Nope. We do not have a group of four. We, however, have this group of two. It cannot overlap to this one. Well, it cannot overlap here. We will, however, have another group. But if we had a one here, this group will overlap and be like this. But that is not the case. Make sure you understand that overlapping thing I'm talking about. Right. So making our groups, we have one, we have another group here, two, we have another group here, three. Any other group we can make. Okay. Any other groups we can make? We have this one. You have to make all the groups. All the ones should be grouped. We have this one. I think we have one last
I
one there.
think, yeah, the one that is to the far right and then the one next to it, bottom right.
Voila, we have another group here. So we have four groups. We started with constructing our truth table. Each row of the truth table represents a square in the Carnot map. We didn't do that here. We went directly from the notation to the Carnot map. After constructing the Carnot map, you then identify your ones. If you are using SOP, therefore, if you are using POS, you identify the zeros. We'll get to that later on. Here we are using SOP. We identified our ones. You group them starting with the largest. Our largest was 2 here because we don't have 8s, we don't have 4s. Our largest was 2. We have a group of those ones. We have 4 groups of those ones. Now we go to the simplifying stage. How do we then come up with the expressions which are simplified? How do we come up with the simplified expressions? Which one? Nope. Nope. Which one is? Right, this one. No. Let's do this the easy way. Easy. Right. Now we want to find our simplified function. Where are we coming from? We came from f is equals to, just for perspective, f is equals to sum of min terms in order 1, 2, 5, 6, 7. Normal way of finding this expression. This is x, y, z plus x, y, z plus x, y, z plus x, y, z plus x, y, z. 1, this is 0, 0, 0, 0. 2, this is 0, 1, 0, 1, 0. 5, this is 1, 0, 1. 6, this is 1, 1, 0, 7, 1, 1, 1. This is the normal expression from the shorthand notation. Anyone who doesn't understand how I came up with that expression? Nope. So we continue. Now the simplified expression from the Kano maps. Reading the K maps. Reading part. Let's explain. How do you read the K map? One, variable which remain constant is 0. Variable which remain constant is 0 along the cell. Along cell is written as the complemented form. If a variable remains constant as a 0 along the cell, it is complemented. So it means if it remains a 1 along the cell, it is uncomplemented. Complement. What is a complement? If you have a variable x, its complement is x bar. If you have a variable x is uncomplemented form, it remains the same as x. That's how you read the K-map. Now we go back. We have a group. Okay, here we are. We have a group. Let's start with the blue group. The blue group here. The blue group we made here. If we move along the group, so if we move in this direction, the variable a changes from 1 to 0. It changes. It doesn't remain constant. So the variable a is out. However, here, these two variables remain the same. These two variables remain the same. If we move from here, this point, the two variables are 0, 1. This point, the two variables are 0, 1. It remains constant, right? So we have 0, 1. What is 0? 0, it goes on to be complemented. 1 remains uncomplemented. It means our F for 0, we have B bar, because this is a B, this is a C. Here we have a C. Other ways of understanding this is to, at the beginning, instead of putting these 0s, 0, 1s, you can do this. For some of products, this is B, C, bar. This is B, C, nope. Something wrong here. 0, 1. So this is B bar C, this is B, C, and this is B, C bar. Anyone
Yes.
Yes, one person is good enough. Right, so it
Yes.
means what remains constant for the blue, along the blue group, is the B bar C. This part remains constant here. Plus, what remains constant for the green one? When we move along the green, when we move from here, this point here, are you able to see the cursor? Or is it only me? Are you able to see the cursor moving here?
Yes.
Right.
Yes.
So if we
Yes.
move from this one to this one, what remains constant? This one here remains constant. True? It remains constant. So we have an A here. Eraser. We have an A here and A bar here. On the green group, when we move from this one to this one, A remains constant. So we put our A here. Then we go to B and C. When we move from this one here to this one here, B bar becomes B. It changes. We do not care. However, C remains as C. 1 remains as 1. We care. So it means we can put our C here. plus, we continue. We go to the red one. When you go to the red one, when you move from this one to this one here, A and A bar, there is a change there. We do not care. However, BC bar remains the same. So we have BC bar plus, we go to the brown one. This brown, when we move from this one here to this one here, A doesn't change. We do K. It remains constant. However, on this side, B becomes B. It remains constant. We K. So we have a B here. C becomes C bar. It changes. It does not remain constant. We don't care. Which means our simplified form will be like this one. This F here is the same as that F there. However, let us do this. This is the same. How do I put it? In terms of X and Y's. In terms of X and Y's, we have Y, Z. We have plus Y, Z bar. We have plus Y, X, Y. Oh, yeah, it will be very difficult. Let me do this. What am I doing here? I just want to sync the examples I gave there with this one. Okay. Let us do this instead. This is A, B, C. Bar plus A bar, B, C bar plus A, B bar, C plus A, B, C bar plus A, B, C. No longer have these X, Y, Z. So this is our F. So in the beginning, there was this function F like this in its canonical form. At the end, we have this F in its simplified form. Instead of using the rules, Boolean algebra, in simplifying this, I'm sure we can all see it is much easier to use the Carnot map to simplify this F to this one. That is the main reason why we use that Carnot map. If I knew how, and if I had the time, and if I didn't want to act like a failure in front of you, I would have simplified this one using the rules. However, I'm not going to do it because I just did it with Carnot. For practice purposes, you can as well simplify this using the rules. Those Boolean algebra rules. You can as well do that. But we live in a world where complicating things is not necessary. You can as well use the Carnot map. That is for 3 variables. We can have another example using 4 variables. We can, but we are not going to. When we have 4 variables, it means we have A, B, C, D. It means we have 2 to the power 4 possible outputs. It means we have 16 possible outputs. It means we have 16 squares, with each square representing 1 row of the truth table, if provided. You can have A, B, and BC for constructing your truth table. So you have your 0, 0, 0, 1, 1, 1, 0, 1, the same here, 0, 0, 0, 1, 1, 1, 0, 1. That is 16 variables for you there. You then go identify your ones, group them, starting with the largest, find the constant. What remains constant in that group? After finding the constant, if it's a 0, it becomes x bar. If it's a 1, it becomes an x. And you continue to find your simplified form. And that is it for Kano maps. Anyone who didn't get where we came from to where we are? Any comments? Minimization of expression. Nope. It means those are distinctions. Those are distinctions. There is a thing about this learning process. Nobody wants you to fail, especially me. Nobody wants you to fail, because if you fail, it means I'm also a failure, and I really hate being one. Nobody wants you to fail. Yeah. I want everyone to get distinctions here, because that is the only way I'm getting promoted from doing this job I'm doing here. So please do not fail. I don't want to be a failure. And with that, I think I can call it a day. I can call it a day. We just did Kano maps, sum of products. Product of sum, identifying the zeros, grouping them. That is for you. That is for you. And I think with that, I'll leave you with an assignment. Yes, I'm trying to find an assignment. For those who do not attend these sessions, I would really encourage everyone at Banapa not sharing this information. You have an assignment. That is your participation point. For those recordings who maybe are a bit tied up in the data, they'll probably do my recordings. It means they will get this message. I am not advising you to share this information with an assignment, please. And so that we are now groups. I don't want to see it anyway. Muna akaona video your assignment, and you will get your participation points. Forgive me for being selfish. There is need to be right. So where is our? Let me see. There we have our assignment. 10 minutes. Our first assignment. Assignments, I think they have 10% of your 100%. You need to be very careful. This is a very large margin, mind you. Only one question. You will be copying, you will be doing everything. You need to get these 10%. You need to get that 10%. Right. Well, so what is our 4 variables? Nope. 4 variables. Yes. All right. We have a function if 4 variables, right? If is equals to sum of min terms 0, 7, 9, 12, 15. I need you to simplify this function. Best way you know how. Boolean algebra, Kano maps. Best way you know how. I need an answer. I need you to simplify this using, obviously, is OP. Right, that is your assignment. And it's due. What's the date? Today is 10. Next week, let's give it a week. It's due email. I don't know the rest. That's my email. All right. I think you have it on your course outlines. You will find it. I don't need anyone asking me what is my email. We should have it by now. And that's it for today. Any questions? Any comments?
Sir, next week on Monday, is there a specific time we should send it by, or?
Before, yes, before we do the lesson. So this is before 8, before 11. In fact, midnight.
Say, can you please make it the assignment a bit clearer? We can see clear.
Guys, can you type the question here? I can't see his writing clearly. You don't need to see my writing. You need to understand what I just said. So this is 16. This is 16 midnight. It means by Sunday you should have submitted. Right, the assignment. You have a function. Take notes. Those you are asking. How many minutes? 5 minutes. You have a function f. F is equal to sum of the min terms 0, 7, 9, 12, 15. I want you to minimize this function using either Boolean algebra or the K-map. Understood? You don't need to see anything. Take notes. Right. How you submit this? You write on a piece of paper. If you have these gadgets we are using here, you can as well do that. Write on a piece of paper. That's the simplest thing to do. Take a photo, turn that photo into a PDF, and you send that PDF to my email. Thank you. Right. We are not sharing this information because I need everyone to participate. And participation comes with watching my videos. If you don't watch my videos, you are going to fail. If you fail, it means I'm also failing at my job. And that is not going to happen, ladies and gentlemen. Let's call it a day. Good afternoon.